Hi, welcome to Continuous Security by Design. We're going to talk about adding container scanning to your DevOps pipeline to be able to identify incidents before our customers do, vulnerabilities and security incidents. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been chasing similar speakers and it hasn't worked out very well. So let's head to robrich.org and we can see that the slides are online right now. So I've got my slides right here. If we head to robrich.org, we can see scroll up to click on presentations, and here's Continuous Security by Design. The slides are online right now. While we're here at robrich.org, let's talk about some of the things that I've done recently. We'll click on About Me, and we see this. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp closer to where you are, hit me up on email or Twitter, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I do a lot with containers and Kubernetes. If you need Docker or Kubernetes consulting or training, hit me up. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's talk about continuous security by design. Jumping ahead a little fast there. Doesn't Kubernetes just do this for me? Isn't that why I moved to containers, so that I didn't have to worry about the security thing? Well, let's take a look at the parts of Kubernetes. In green, we see the control plane. In blue, we see the worker nodes. We can see that Kubernetes has a lot of microservices, but at best, Kubernetes' microservices are focused on protecting Kubernetes, keeping our process running. Once we're inside our particular container, then the security is up to us. Well, let's look at Docker. Perhaps Docker has this mechanism. We've seen slides like this where we compare Docker to virtual machines. Now, we do have a box, we do have a hypervisor, we do have that separation between processes. A process can't exactly reach into the other process's memory space, but they can reach across the network to every other container. So if we pop one container, we can pivot and start popping other containers too. In short, Kubernetes is a cluster of machines. At best, it's a firewall in front of our container. But Kubernetes focuses on getting our application started, not on keeping our application secure. So what is a Docker container? Well, a Docker container has a file system. It has users, a process, ports. This sounds a whole lot like, well, a Linux machine. And we know how to secure a Linux machine. We uninstall unneeded software. We reduce the unnecessary users. But this Linux virtual machine is a little bit different. It's ephemeral, isomorphic, and deterministic, or short-lived, unchanging, and identical every time. So it's not quite a Linux machine. So as we look at some of those pieces, we can take a look at some of the pieces that we need to do to be able to secure our containers. By default, every container can communicate with every other container in the network. Now, this is true of Docker and of Kubernetes. A Kubernetes namespace is not a security boundary. A Kubernetes namespace is an organizational boundary. Containers can still reach across the Kubernetes network to every other container in the cluster. So if we pop any container, we can pivot to pop other containers as well, and that attack can continue on. Well, how do we discover this? How do we prevent this? How do we correct from this? As we look at threat vectors, we can think of threat vectors from perhaps CVE in an installed software. Maybe a custom app has a vulnerability. Maybe we've exposed sensitive data through our API. Now, as we start to centralize these, we can think of these as I might have an attack surface from outside. I might have an attack surface from underneath. And then once they've attacked this container, what can they pivot to? Some of the more famous attacks have been attacks on pretty benign systems. They came in through the HVAC system, or they compromised the battery backup system. So once they get in, what can they pivot to? The cool part about containers is that they are ephemeral. They are identical. So we don't need to do anything like scrubbing a container to remove the virus. If a container has a compromised scenario, then we just kill off that container and start a new one, and that container is now clean. Now, if they're still in our cluster, then they might pivot back to this machine, or if this container still has that vulnerability, they might be able to attack it again. But we don't need to do things like scrubbing the machine. That's really neat. As software developers, we build various tests to be able to validate that our software works correctly. Unit and integration tests, static analysis of source code. We can inventory our machine for known vulnerabilities. We can work on open source license compliance. And then ultimately, we can take the results of these tests and decide if we're going to go or not go. First off, integration tests and unit tests. There's nothing that I can add to this discussion. Do it. Next up, source code analysis tools. I'm not here to sell software, but as you grab these slides from robrich.org, you can click on any of these blue links to learn more about that product. Maybe that will help get you past the blank page, where you can find the static code analysis product that works for you. Static code analysis is the process of looking at source code to identify vulnerabilities or not best practices. Next, license analysis. You can grab the links from robrich.org and find the static license analysis tool that works for you. Do you have GPL code and thus your software might become open source unexpectedly? Here we can validate the licenses of the dependencies and ensure that we're compliant. Next up, policy validation. Now we take the results of all of these tests and we decide if we can deploy the software. Now, one of the things that's really easy to do is to be very harsh here, to say, if there are any failing unit tests or any license validation failures or any static analysis failures, we're just not going to deploy. Well, what if we have an attack vector, but we don't yet have a remedy? What if we have a virus without a cure? I get the sense that the world is learning this lesson. Should we just shut everything down? Should we try and hobble along? Should we just proceed as normal, presuming that, we will lose things, but those are the casualties of doing business here? Yeah, we need to probably be a whole lot more pragmatic than just saying, if there is anything, we shut it off. So we're quite a bit through this presentation so far. So where's the serverless? Where's the security piece? We haven't talked about container scanning yet. Let's dig in exactly there, container scanning. Now, you may not have this in your build or deployment system today, but let me show you how it can be a really invaluable tool in hardening and correctively responding to security vulnerabilities that might be in your system. As we do container scanning, we're going to do two processes. The first, we're going to list the installed software on this machine. And second, we're going to compare that to a list of known vulnerabilities. Now, as we list the software in the machine, we may look at lots of different sources. Maybe we're looking at apt packages and Debian tarballs, but we're also looking at NPM dependencies and Maven dependencies, pip packages. We want to look not only at the dependencies for our application, but also the dependencies of our container. With that list of software, together with the versions of each of those packages, we can compare that to a list of known vulnerabilities, and we can validate if our system is secure. So when should we scan? Well, there's lots of different places that we can add container scanning, and each of them have some assumptions. So we could incorporate this into the build pipeline. We could just add it as one of the steps. After you finish all the integration and unit tests, maybe the static code analysis, let's kick off a container scan. Now, container scanning does take some time. So if we're going to wait our build for the container scan to finish, this may take a long time. A good rule of thumb for a build is to finish in 10 minutes. And container scans might take 10 minutes. So if we have a build that's about 10 minutes right now and we add container scan, then that build is 20 minutes. So maybe we can only kick off the container scanning, but not analyze the results in our build pipeline. That's okay. Next, we could look inside of our container registry. Now, the beautiful thing is once we've built a container and published it either to Docker Hub or our internal registry, then those are the containers that might get deployed to our cluster. So perhaps we take a look at each of those containers. Now, the beautiful thing here, because containers are ephemeral, they're identical every time, then we can take a look at a container, and if the SHA of this container matches one that we've scanned previously, we already know the software installed in it. We don't need to rescan it. That's the part that takes a long time. We can just now take that list of bill of materials of software, compare it to our vulnerability database, and know if our system is compromised. Next, we can take a look at Kubernetes webhooks. Now, these are really great. At the point where our pod launches, then we can do various pieces to dig in and validate that our system is as we expect. Let's set that one aside for now. Next, we can take a look at the content inside of our cluster. Let's take a look at all of the containers that are running inside of our cluster and validate that we've scanned them and compare the contents to our vulnerability database. Now, each of these have some assumptions. We might want to say, hey, let's put it in our DevOps pipeline. If the container comes out clean out of our DevOps pipeline, then we know everything from here on is clean. But the assumption there is that our container went through the DevOps pipeline. What if we pulled a container from another registry? Next off, we might scan our container registry. There's an assumption here as well, that all of our containers run through our private registry. What if one of our systems pulls a container straight from Docker Hub or another registry? In this case, we may not see the content until it's already deployed in our cluster. So scanning in our cluster. Now, arguably it's too late, it's already running, but maybe this is just the double check where we go validate that we've seen all these containers before. And Kubernetes webhooks, let's double click in there because that's going to be really cool. As Kubernetes pods and containers get launched, they go through this process. There's a mutating admission webhook where in series, it calls each of the endpoints to validate that this container is as expected. And each of those endpoints could mutate the YAML, or in this case, JSON, to form content. This is a great place to inject sidecars. We also have the validating admission webhook. And here in parallel, it calls each webhook, and the webhook can answer yes or no. So maybe here in the validating admission webhook, we validate that we've scanned our container and that the content is as expected. Now, this does mean that if we haven't seen the container before, we start the scan here, and 10 minutes later, we have the result. So maybe this service fails to start for 10 minutes and then start successfully. Is that an acceptable acceptable time frame? If so, then we know that everything running inside of our cluster now has passed this validating admission webhook. That can be the perfect time. So looking at this list, maybe we do it in all the places. Maybe in our DevOps pipeline, we kick off the scan. If we can't wait long enough, then in our container registry, we'll go look for vulnerable containers. If they don't meet our threshold, then maybe we'll delete those containers out of the registry. In our validating webhook, we can say, hey, if you haven't been scanned yet, I'm going to kick it off. And until you pass, I'm not going to let you start. And then periodically, we'll scan our cluster to validate that all of the containers have been scanned. Now, the cool part is that that scan is two pieces. We take a look at the content in our container, and we compare it to our software vulnerability database. So periodically, we can go recheck all the containers. A new vulnerability came out. Which of our containers are exposed? We can quickly enumerate all the containers that have that version of the software installed and know which containers we need to rebuild to become secure. So what are container scanning softwares? Well, this is definitely not an exhaustive list, but as you grab these slides from robrich.org, you can click through each of these packages and compare and contrast their features, or start to discover other packages that might best meet the needs of your organization. What is your tolerance for vulnerabilities? What is your need for scanning? Do you need to scan both software packages and Linux packages, or do you only need one or the other? How frequently do you want to scan? And what format of results do you want? Now, for the purpose of this demo, we need to pick one. So I'm going to pick Anchor. Anchor isn't particularly wonderful, but it is free and open source, and that is amazing. So how might I include Anchor in my build? Well, it's nice that Anchor will scan both the software installed on my machine and the software that my software depends on. But it's not fast. It does take about 10 minutes to scan, and the docs are really not great. So first step, let's download the docker compose.yaml file. Now, you could also deploy it to Kubernetes. Here in this docker compose.yaml, it describes all of the details about how to spin up this cluster. Let's flip over to that docker compose file, and we can see that, well, they're kind of a container in each of these microservices. So I would argue this isn't microservices, this is a distributed monolith, but it's cool. Now, once we've got all the containers in place, now we can exec into a container or pip install the Anchor CLI, and now we have access to Anchor. Our first step is to do an Anchor CLI system status and an Anchor CLI feeds list. Now, the cool part about this is that kicks off the sync to go download all of the definitions of vulnerabilities. The docs say in one place it'll take a minute or two, and in another place it says it takes 10 minutes. It took me significantly longer. Here's the update list. You can see that this one started on the 20th, and this one ended on the 23rd. It took me far more than 10 minutes to get this to go. It took me days. Now that's okay, but that initial setup is only one time. Periodically, Anchor will go download new definitions and allow us to more closely identify this concern. Next, we can start to run the Anchor CLI commands. Now, the first one, add container, that queues it to be scanned. It's a non-blocking operation. We could choose next to wait for it, and in this case, I have. And then we can get the results. Once we get the results, we could take a look at particular content from particular things. So we could look at vulnerabilities in, for example, the OS or in NPM or GEM. In this case, I've chosen to get them all. And we can also get that bill of materials, that list of software that's installed. This includes all of the software, both Linux packages and the libraries that my application depends on. So let's dig in and take a look at how we might transform a build for scanning. Here's my original build where it just does a Docker build, a Docker push, and a kubectl apply. I'm going to add those steps to do the container scanning here. So in this case, I'm going to pass in my image and my Docker file so it can do a little bit deeper inspection. I'll wait for that to go. Now that does take about 10 minutes, so I've definitely blown my DevOps pipeline budget there. And then let me go look at the vulnerabilities. Now I'll send that to vuln.json and then start to examine it. In this case, I'm examining it with JQ, and I'm saying, if there are any vulnerabilities at all, I'm going to fail the build. Now, we talked about how that probably isn't very pragmatic. There are lots of places where I might have a vulnerability discovered without a cure. Next, I'm going to grab the entire content list and save that off to content.json. Now, I need to store vulnerability.json and content.json in my build artifacts so that periodically I can recompare my vulnerability database to the software bill of materials and understand if my container is newly discovered as vulnerable. And now that I've validated that this container is good enough, I'll continue pushing that and applying it into Kubernetes. Next up, let's take a look at how we might include that with GitHub Actions. Now, the cool part is that this GitHub action kind of does all of those pieces together. So I have a build here that two different houses that you can click through here. And one of them, I have pass. This includes no vulnerabilities in my software. And a second one called fail that does. Now, the only difference between these is in the fail repository, I committed a vulnerable package, where in the past one, I did not. So let's take a look at the GitHub Actions build and see how that was done. Now, first off, I checked out my content and I built my image, as we would with anything. Next, I fire up the Anchor scan. Now, I'm not sure why fail build true doesn't actually fail the build, but that's okay. I probably didn't want to fail the build at this point anyway. So I'm going to go grab all of the contents and echo them to the build log. That can be kind of nice, maybe a smidge verbose, but I will also upload those as artifacts. So now I know the list of bill of materials for my container given this image hash, and I can do that periodically to validate that my container is still secure. Now I'm specifically going to do this if always. I don't want a failure in the build to not publish my build results. That would be really unfortunate. And then next, I'm going to go look at my vulnerabilities. Now, perhaps we say, I'm not going to let the container go if it has any high vulnerabilities, or maybe any medium or larger that aren't patched vulnerabilities. The software that we push may still be vulnerable, but it's probably better than the software that we have. So perhaps we need to let it go, even if it does have some concerns. We definitely need to be pragmatic there. So we've got build in place. We saw that Kubernetes really only protects itself. The process of securing the content within our container is our responsibility. We can use container scanning to periodically enumerate the content in new containers and periodically compare that to the vulnerability database. Do we have an incident? If so, we can go kick off that build, rebuild a more secure version of this container, and publish that without exposing that content to our users. Now, the beautiful thing there, if we're recomparing our bill of materials to our vulnerability database, that's going to happen really quickly. We should empower our ops team to be able to rebuild the main branch, the production branch, and redeploy those new containers. If we have a good suite of unit tests, then we know our software is good and we can send it up to production. Maybe nightly, maybe weekly. We should rebuild really frequently to get patched versions of software. This has been a lot of fun getting to show you container scanning. I've had a lot of fun getting to join you here at IRConf. If you're watching this video later, hit me up at Rob_Rich, and let's continue the conversation on Twitter.